So I'm just going to do a review, and I'm going to label these powers. So these, if you guys want to label yours, you can just call them, again, the rules of exponents. Please write them down with their name, because I just want to make sure, guys, we're going to be labeling them, talking about them. I want to make sure you have the right title for everything that we talk about. So rules of exponents. And I want them all to be in the same spot, too, because we're going to be using all of these rules. The first rule of exponent, though, is the power rule, which you guys should definitely be familiar with. When you have two exponents, as long as they have the same base, x, and you're multiplying them, you simply add the powers. Does everybody agree with that? Yes, everybody remembers that. Sorry, that's not the power rule. That is the product rule. Good. Next one is the quotient rule. The quotient rule is very similar to the product rule. It just states whenever you have two exponents that you are dividing, as long as the base is the same, you subtract the powers.
What is that?
Quotient. Yep. The next one is actually the power rule. And what the power rule states is whenever you have an exponent raised to a power, you multiply them. Everybody gets these all the time confused. So I'm just saying, hey, let's go over them again. Let's spend the time going in class, and let's go through them. The next one is the zero power rule. And what the zero exponent rule basically states is if you have an exponent with any base raised to the 0 power, that's always going to equal 1. Any number raised to the 0 power always equals 1. Doesn't matter what the number is, what the variable is. It's going to equal 1. I don't have time to go over that right now, but you can just write that down as a rule. I could explain all of these, but I just don't have time to do them anymore because this is a review session right now. So just remember it or write down. So now let's get into the next ones. The power of product rule. So the power of product rule basically states that whenever I have a variable, an expression separated by multiplication. Do you guys see how this is separated by multiplication? Whenever I have an expression separated by multiplication, I distribute my exponent or my power to both of my terms, or all of my terms, really. It doesn't matter how many terms there are. OK? But please just remember, guys, please, please, please note that x times y squared is not x squared plus y squared. Right? That does not work. You cannot do that. Because what are my two terms separated by? Addition. You cannot distribute a power across addition. You can across multiplication, not addition or subtraction. OK? What's x plus y squared? That's x plus y times x plus y. You have to do FOIL. OK? All right. Big common mistake. Next one is the power to quotient rule. Power to quotient rule is just like the power to product rule. If you have a quotient of two exponents or of any terms, doesn't matter if it has a power, doesn't matter if it's an exponent or not, and it doesn't matter how many terms there are. If you have the quotient raised to a power, every single term, as long as they're separated by multiplication and division, every single term you have to distribute. Let's make this an n. Sorry. Every single term needs to be that n needs to be distributed to. OK? So we have power to product, power to quotient. Then we also have the negative rule. This is one that students started having issues with. If you guys remember the negative exponent rule, if I have x to the negative n, a lot of times we don't like to write them with negative powers. We want them to have positive powers. So we write it in the denominator so we can have the power be positive. Or if I have 1 over x to the negative m, to rewrite that as a positive, I can rewrite that in the numerator. That's the negative exponent rule. If you have an exponent raised to the negative power, to write it as a positive power, you write it in the denominator. Do you see how this is already in the numerator? So you just write it in the denominator. to make it positive. If it's negative in the denominator, put it in the numerator to make it positive.
Is that the negative rule?
Yep, negative exponent rule. So that's all stuff that you have been presented before. Now we're going to get into the rational power rule. And this will be the last one of your rules of exponents. Rational power rule, if basically you guys have a to the m over n, what that means is that's the same thing as the nth root of a to the m. Or nth root of a to the m, if I give you an expression, I say write it as a rational power, that's the same thing as a to the m over n. Okay? Just notice that the denominator in the rational power is the same as the index. The numerator in the rational power is the same thing as what your radicand is being raised to. Okay? Those are all of your rules of exponents. And you will be using them during lunch. Yes. So what I'd like you guys